last thing I think I was talking about there. Strep Pneumoniae is an alpha hemolytic streptococcus. It is not put in the Lancefield classification because it's not beta hemolytic. The pneumococcus causes a variety of different kinds of illnesses. The one that is most important is pneumococcal pneumonia, but it causes meningitis in very young children below the age of 3 months or so. Is the major cause of otitis media, which is an ear infection. Also is the major cause of sinusitis. When you get sinus infections, it's usually Strep Pneumoniae. The organism is carried around by about 30% of the population at any one time in the back of your throat. It normally does not cause you problems until it gets into the lower respiratory tract. And here, usually, it's the result of a viral infection, such as influenza, that destroys the ciliated epithelial cells for the ciliary escalator, smoking, people that live on the streets that are constantly exposed to dampness and cold, that depresses the ciliary escalator. It has a variety of virulence factors, and I mentioned 3 of them. First of all, the most important virulence factor is the capsule that the organism produces around it. We often have opsonizing antibodies to it, but if you come in contact with someone who could be shedding a different strain of the organism, and I mentioned that there are more than, I don't know whether I gave you the number, the last time I looked, 90 serotypes of Streptococcus pneumoniae. What makes one type different than the next is the capsule. When the organism gets down into the alveoli, the first thing that your body tries to do is to trap it against the wall of the alveoli with the alveolar dust cells. And this process is called surface phagocytosis. If this is not successful, the organism will begin to replicate there and produce a toxic protein called pneumolysin. The pneumolysin is going to damage the tissue and the capillaries and cause an inflammatory response. There also will be cell wall components of this organism that will contribute to the inflammatory response. The bottom line is the alveoli fill up with fluid. And this fluid is warm, it's rich in protein, and will facilitate the growth of the pneumococcus. Pneumococcal pneumonia has an abrupt onset with fever, chills, shortness of breath. Diagnosis is going to be made by culturing a sputum culture. People will cough up a rusty-colored sputum. If you look at that sputum, you'll see neutrophils, and you'll see gram-positive diplococci. That's usually plated on blood agar, and usually to differentiate it from normal alpha hemolytic strep, which are normal flora, they put a little disc, like an antibiotic disc, that has a bile salt called optochin. And the pneumococcus is sensitive to optochin. And if you get a optochin-sensitive alpha hemolytic strep, this usually confirms the diagnosis. Treatment would be to intervene with an antibiotic as quickly as possible. Usually penicillin works well, erythromycin will work well. Diuretics are used to try to get the fluid out of the lungs. This is difficult to do. It's a major killer for elderly individuals, and still is a continual problem for us. The Group B, I talked about Group A streptococci, Group B, and Group D, so we should be done with them. The last group of the pyogenic cocci that I want to talk about is the genus Neisseria. capital Neisseria, the genus Neisseria. Unlike Staphylococcus and Streptococcus, the genus Neisseria is a gram-negative Diplococcus. And there are several members of this genus. Some are pathogens, most are not. The non-pathogenic Neisseria are easily grown on Tryptocase soy agar, or TSA. They grow at room temperature even. And they are normal residents of the mucous membranes of the upper respiratory tract, the vaginal mucosa, and they are not pathogenic. They go by such names as Neisseria Mucosa, M-U-C-O-S-A, Neisseria flava, F-L-A-V-A. It's a yellow one. Neisseria sicca, S-I-C-C-A. And they're easily isolated and are often seen with the alpha hemolytic strep when you do a throat culture. The pathogenic Neisseria are not normal residents of the body, and their recovery from a particular body site will confirm the diagnosis of a disease caused by them. The two important members of this genus from a pathogenic standpoint are Neisseria Gonorrhoeae, Gonorrhea, Neisseria Gonorrhoeae. It's also called the Gonococcus. And the other organism is called Neisseria Meningitis, Meningitidis. This is the cause of meningococcal disease. These two members of this genus are the pathogenic ones. We talked a little bit about Neisseria Meningitidis when I showed you the video Killer Disease on Campus, but we can go over this again quickly. The pathogenic Neisseria all produce an enzyme, or all members of the genus Neisseria produce an enzyme called cytochrome oxidase, so that when we characterize the genus Neisseria, we say they are gram-negative, oxidase-positive diplococci. And you'll do the oxidase test in the laboratory in 2 weeks. The other important aspect of the pathogenic Neisseria is that they require carbon dioxide in order to grow, usually 5 to 8% carbon dioxide. And we use the term microaerophilic, so that when we're talking about the pathogenic Neisseria, they are gram-negative, oxidase-positive, microaerophilic diplococci. These organisms are difficult to grow. In other words, is another big word. We use the word fastidious. They won't grow at room temperature. They won't grow on TSA. They use enriched media such as blood agar or chocolate agar in order to grow the genus Neisseria. Now, the genus Neisseria, Neisseria meningitidis first, has several different virulence factors with it. The first virulence factor is a capsule that the organism produces around it. And we recognize at least 8 serotypes of Neisseria meningitidis. Each one differs by the makeup of the capsule. This means you can get recurrent infection if you come in contact with a different strain. This gene, the Neisseria meningitidis, also produces an enzyme called IgAase. And IgAase is an enzyme that will degrade IgA, which is an important antibody that we have on our mucous membranes. Finally, it has endotoxin associated with its cell wall. Being gram-negative, this organism has endotoxin, and it's the endotoxin and the capsule that are going to be the major virulence factor. The organism is a transient resident of humans at different times of the year. You usually have antibody to the strain that you would carry around. So your immunity is based on the production of opsonizing antibody to the microbial capsule, and that protects you. The organism is spread primarily by what we call droplet infection. And when a person coughs or talks, he can transmit that organism from one person to another. The person who is going to contract meningococcal disease is going to come in contact with a strain of the meningococcus that he has not seen before, so that he will come in contact with an individual who is shedding through coughing a strain that has a capsular polysaccharide that he's never seen before. Usually overcrowding conditions and bringing people together from different geographical locations are the conditions that favor the spread of this illness, such as army barracks, dorm rooms, locker rooms, things like this. You bring people together from different locations, you put them in close proximity, and then that will enhance their ability to come in contact with a strain that they may not have seen before. The organism localizes in the back of your throat, and what will happen next depends on where the organism goes. In most cases, it's a limited infection. It will begin as a sore throat and often end in that place. Occasionally and rarely, it enters the bloodstream from the back of the throat. When it does, it can cause two distinct forms of illness. In one form of the illness, the organism localizes between the outer membranes of the meninges. I think they're the pia mater and the dura mater. And here it will cause an inflammatory reaction that will cause those membranes to put pressure on the brain. And when that happens, you get the form of meningitis. The term meningitis means an inflammation of the meninges, which is going to start with a stiff neck, a high fever, vomiting. The diagnosis is made by taking cerebral spinal fluid, and you can see gram-negative diplococci as well as neutrophils in the cerebral spinal fluid. Because the disease is life-threatening, before the microbiology is confirmed, they will begin treatment. And treatment, again, would be the use of antibiotics. The early antibiotics that were used were sulfa drugs. These were later replaced with the penicillins for the treatment of meningococcal meningitis. The more severe form of this is a septic form, where the organism rapidly replicates in the bloodstream. It releases endotoxin that damages endothelial cells. The endothelial cells will then cause bleeding into the tissue, so that one would see as an early symptom a rash that will develop, which is called a petechial rash, Petchial, a petechial, Peth, how did I spell that? Pech, oh God, petechial, Petchial, I think. This petechial rash would be one of the symptoms that will develop. As the disease progresses, often the extremities are affected because of the decreased blood flow to the tissue, and you saw the loss of fingers and toes that occurred in the individuals that had this form of the illness. This form of the illness has a much higher fatality rate than the meningococcal meningitis, which even if you're treated and cured, it can have side effects such as deafness and other complications of the illness. There are about 3,000 cases of meningococcal disease a year, and it is preventable in some instances with a vaccine. The vaccine works against 3 or 4 of the different strains. It consists of the microbial capsule that protects against type A, type C. I think there's a W125 and 1 or 2 other ones. What it does not protect us against is type B. The type B capsule of the meningococcus represents antigenic mimicry, and we can't produce a vaccine without having an immune response directed against our own nervous tissue. Now, while it's 3,000 cases here, meningococcal meningitis worldwide, particularly in Africa, may kill 30,000 people a year. So it is still a very important clinical disease. Now, the other member of the genus that is important is the Gonococcus, or Neisseria Gonorrhoeae. And this organism infects about 400,000 people a year. And, pardon? In this country, every year, between 350,000 400,000 individuals contract gonorrhea. Now, the word gonorrhea has an interesting story. The word gonorrhea means literally flow of seed, because the primary symptom in a male is a purulent urethral exudate. And that exudate from the male urethra was confused with semen. And this is where the word gonorrhea comes from. Interestingly, in the late 1700s, an English physician by the name of John Hunter was studying both, wanted to know more about syphilis or gonorrhea, and he infected himself with the pus from gonorrhea. Unfortunately, the guy also had syphilis, and he got both illnesses, and he screwed up the medical literature for a number of years, co-describing the symptoms that occurred for 2 different diseases. And he's not the only physician that did things like this. More recently, we've had physicians prove or try to prove that AIDS was caused by a virus by inoculating themselves with the AIDS virus. But Hunter it was an interesting thing that he did. Neisseria gonorrhoeae, again, like the meningococcus, is not a normal resident of the body. And when you recover it, it's going to confirm the diagnosis of the illness. The gonococcus, as it's known, is capable of infecting a variety of different body sites. But those body sites have to have the right kinds of cells, so that normally you think of gonorrhea in the male infecting the urethra. And it doesn't affect all of the cells in the urethra. It binds specifically to what are called columnar epithelial cells, or cells like the transitional epithelial cells. It cannot bind to squamous epithelial cells. So it doesn't colonize the vaginal mucosa. The cells are not the right kind. Where it will bind with the female is the cervix, and the primary site of infection in the female will be the cervix. In the male, the primary site of infection would be the urethra. But it will also colonize the pharyngeal mucosa and cause pharyngeal gonorrhea. It will colonize the rectal mucosa and cause anorectal gonorrhea. It will colonize the eye, so that if a mother has gonorrhea at the time of birth, the organism will adhere to the eye and cause a condition called ophthalmia, O-P-H-T-H-A-L-M-I-A, ophthalmia. The other word with this is neonatorum, N-E-O-N-A-T-O-R-U-M. And I'll show you pictures of ophthalmia neonatorum in a newborn where a mother had gonorrhea. Normally this is preventable, and they use either silver nitrate drops. Some were using antibiotic solutions to prevent this from developing in a newborn. If we look at the virulence factors with the gonococcus, of which there are several, probably the most important part, or one of the most important parts of the gonococcus, is that it's surrounded by pili. And we have 8 different strains of Neisseria gonorrhoeae. What makes one strain different from the next is the makeup of the pilin that make the pili. That means you can get gonorrhea several different times by coming in contact with different strains of the organism. In addition to the pili, the organism will produce IgAase, which will facilitate its survival on a mucous membrane. It has endotoxin in its cell wall, and the endotoxin will cause the inflammatory response that leads to the development of the symptoms in this illness. The organism is transmitted by what we call direct contact. Gonorrhea and syphilis and chlamydia and many of these sexually transmitted diseases are direct contact disease. You need direct contact between an infected host and a susceptible host. And not always does the initial contact lead to the disease process. Matter of fact, the first contact you may have with an individual that is shedding the organism, it may only be 30% or 40% chance that you would contract the illness. Now, if you have 7 contacts within one evening or 2 evenings or a weekend, that greatly enhances your chance of getting this. And the transmission, if we look at how the transmission will go, there are a variety of different ways depending on the orientation here. And let's look first at what we would have as a classical transmission between an infected female and a poor unsuspecting male. What can I say? The problem with gonorrhea is the female. It always has been, it always will be. It goes back to the apple and, the garden and all that. Because most females don't know they have gonorrhea, at least initially, because they will be asymptomatic. Maybe as high as 60% of females will be asymptomatic. And as a result, they can easily transmit the organism from the infected female to the male. The site of the infection in the female is usually the cervix. If the urethra is involved, she will be very lucky because she will know that something is wrong. She will have pain and burning and a urethral discharge that would resemble the male. But very often the urethra may not be involved, and it's the cervix that will be the source of the organism. Now the male will have direct contact. The organism enters the urethra of the male, and usually in 3 or 4 days or so, symptoms will appear. The organism is going to adhere to the cells, the columnar epithelial cells that line the urethra. And here it will pass between those cells, or actually be phagocytized by those cells and pass right through them. It's an interesting thing, and you can look at electron micrographs and you can see the gonococcus. It adheres to the lining of the urethra, and then it passes right through those cells that line the urethra into the deeper tissue. Now, once it's in the deeper tissue, many strains have a miniature capsule, which is called a K envelope. It's not really a true capsule like you have with a Meningococcus, but it allows the organism then to persist in the tissue and then causes the release, or allows the release, of endotoxin. And it's the endotoxin that's going to attract white blood cells, particularly neutrophils, to the site of the infection. Now, as the infection progresses, the urethra is going to fill up with pus. And if you look at that pus, you'll see gram-negative diplococci, and you'll see neutrophils. The gram-negative diplococci will be both within the neutrophil and outside of the neutrophil. And this is diagnostic for the male. Gonorrhea in the male is easily diagnosed. Matter of fact, many years ago, I had one of my students in this class. I wasn't teaching nursing classes. It was a general bacteriology class. I came in on a Monday night to check something, and he's sitting in the lab looking, and he didn't want me to look in the microscope, and that's when I wanted to look in the microscope. And when I looked there, I knew immediately what he had, and I said, "You know what you have?" And he said, "Yes." And he said, "You said it was 30% we would get this or could get this." And I said, "Well, how many contacts have you had this weekend?" And I don't know, 8 or 10 or whatever. He said, "It's not 30% anymore." So he diagnosed his own condition. He's a radiologist out in Utah now. He has more money than God. But anyway, I haven't heard from him in years. It was back when Marshall had a swim team. They used to have a very good swim team here, by the way. That's why they built that natatorium. But he was from Florida, and he diagnosed his own condition. So in the case of the male, the symptoms are very obvious. You have burn, pain, purulent discharge, and during that period, you are not going to transmit the disease. It's much too painful to have sex when you have pus coming out of the urethral meatus. It's not transmitted then. But before those symptoms appear is when the male can transmit it then to the female. As I mentioned, diagnosis with a male is easy, usually a direct gram stain, and you can begin treatment. Now, that person can transmit that to an unsuspecting female following sexual contact. And again, not when those symptoms are appearing, but before those symptoms appear, the organism can be transmitted. And again, the primary site of the infection is the cervix. If the urethra becomes involved, she'll have the symptoms that are very similar to the male.
What do you mean by that?
Pardon? I can't hear you.
What do you mean by the urethra is involved?
If the organism gets into the female urethra, then it's going to cause the same symptoms that the male will have. There'll be a purulent discharge. It will be white. All you'd have to do is do a gram stain. You'll see this exact same thing. But if that does not happen, the site of the infection is going to be the cervix. And what will happen is that it will be asymptomatic. And then following the next menstrual period, what's going to happen with the uterine contractions, the organism is going to be drawn up into the fallopian tubes. And when it gets into the fallopian tubes, it's going to initiate the same kind of problems that can occur in the male. And I didn't mention what can happen in the male with an untreated case. what will happen is where the organism entered through the urethral lining, scar tissue can form. And as that scar tissue accumulates, it can plug the urethra. This is called urethral stricture, so that this will prevent the passage of urine out of the body, and that will have to be opened up. So they call the rotor-rooter people, and they will come and they will open up the urethra with a fine wire catheter and use different bore sizes to open it up.
I don't know how they do it now, but I was talking to a dude that had been
Yeah, I know. One of your friends, okay.
It was like a long time
You see
ago
the
in Army.
tattoos, and he's in the Army,
But he
right?
said he was in the field and he ended up he couldn't pee after a while.
Yeah.
And they stuck like a metal rod in there and pushed a button and they had to like pull it out. Like that.
Doesn't that sound like rotor-rooter?
Yeah.
I just had a plumber come to my house. I had a plugged shower drain and a thing. What's a plumber charge an hour? You guys ought to all be plumbers. You're wasting your damn time. He was there no more than an hour, and he had to get in his damn truck and go back to get a saw to cut a pipe, and I was still billed for that. He was there for like an hour, and it was $225. This is the wrong... Pardon?
You got to do a lot to get a plumbing license.
I don't care. I can get a license for $225 an hour.
That's a toilet and a shower.
It wasn't a toilet. It was a sink, a bathroom sink.
Nasty stuff. I don't know more money than that.
Oh, man. I'm not hiring you if I would have known how much that was. Anyway, the same kind of thing, the same blockage type thing can happen with a female as a complication. And this occurs in the fallopian tubes. Scar tissue will begin to form. Fluid will accumulate in those tubes. And then you're going to get a mixed infection. And it's going to go by a term called PID, pelvic inflammatory disease, or salpingitis, SALPINGITIS, which is going to be a gonococcal infection involving the fallopian tubes. Now, treatment with antibiotic is not nearly as effective, and usually you're going to have surgery to cut out the diseased portion of the tube, and certainly this can lead to sterility. The organism can also cause a very painful, crippling arthritis as a complication of the illness. Now, diagnosis of gonorrhea in the female is more complicated because direct gram stains are of no value. So what individuals are told to do, at least in medical school, is to swab every orifice, not only the cervix, but the pharynx, the rectum, and you plate it onto a selective medium. And the medium that is selective is called Thayer-Martin agar, Thayer-Martin. They also use another medium called chocolate agar, Chocolate, chocolate agar. Both of these media have antibiotics added to them, and the antibiotic that they add to the Thayer-Martin agar is called VCN inhibitor. The V is for vancomycin, and that will inhibit gram-positive organisms. The C is colistin, Colistin, and that will inhibit the gram-negative bacteria. And the N is for nystatin, Nystatin, and that will inhibit the yeast. So what you're doing is you're swabbing the cervix or the vaginal mucosa, you're suppressing the normal flora, and then you plate onto Thayer-Martin agar or chocolate agar, and then those plates are placed in what's called a candle jar or a CO2 incubator. Yes.
What does the vancomycin inhibit?
Gram-positive organisms like staph and strep. The candle jar is just a great big pickle jar that you put the plates in, you put a candle on it, and then you tighten the lid, you light the candle, and then as it uses up the oxygen and generates CO2, that will support the growth of the organism. The point is to confirm the diagnosis of gonorrhea in a female involves direct culture methods. You isolate and identify the organism. And if you isolate a gram-negative Diplococcus as oxidase-positive, microaerophilic, and we didn't talk about the carbohydrate fermentations, this will confirm the diagnosis. There's not a vaccine for this illness. Treatment then, once it has been diagnosed, would be the use of antibiotics. For many years, penicillin was the antibiotic of choice, but for the last 20 or so, they've had resistant strains. These resistant strains are called PPNG strains. The first P stands for penicillinase. The second P, producing. The next is, the N is Neisseria, and the G is gonorrhea. So if you had a PPNG strain and you tried to treat it with penicillin, you'd have no success with this. Antibiotics that would be used for these strains, one was called spectinomycin, S-P-E-C-T-I-N-O-M-Y-C-I-N, spectinomycin. S-P-E-C-T-I-N-O-M-Y-C-I-N. They now also use cephalosporins, which are like the penicillins in the treatment of this. Some strains, or people who can't take some of these, tetracycline can be given orally for 2 weeks for the treatment of it. But they'll probably do a culture and sensitivity to know which antibiotic would be most useful.
What was the N and the PP and G?
The N is Neisseria. Penicillinase producing Neisseria gonorrhoeae. The organism, as I mentioned, can colonize other body sites. One of the sites that it will colonize is the pharyngeal mucosa. It will produce symptoms that resemble strep throat. There will be an inflammatory reaction, a very painful throat with pus associated with it. It's important that when someone presents with a pharyngitis, and if there's pus, that a culture is done and not a supposition that it's always Streptococcus. A number of years ago, and I forget how many, I was lecturing over at Cabell Huntington Hospital. I used to lecture to the med techs over there. It was good because they put me on videotape, and then I didn't have to come back. I would come back every few years and do this. And I came back and I said to some of the people, "Have you seen any gonorrhea lately?" And they said, "Yeah, but you're not going to believe it." And I said, "I'll bet it was a young female," because that's usually what they're going to be culturing in the lab. And they said, "That's right, except she was 4 years old." And I said, "Where did that come from?" It was a pharyngeal case of gonorrhea. And you better be careful that you don't go oops and make a misdiagnosis, because you're going to be sued from here to hell and back if you're wrong. And it turned out they weren't wrong, and it was an example of one of the family abusing one of the family members with this. But had it not been cultured and just put on penicillin and it was a sore throat, go away, this would have continued on and on probably. So you can't just always make an assumption based on a symptom that it's always going to be this. And so the organism can cause problems in other body sites. And I mentioned the eye, I mentioned the pharynx. In certain risk groups, there's much higher incidence of rectal and pharyngeal gonorrhea than in other groups. Okay, we talked about transmission. Gonorrhea represents a classic venereal disease. The word venereal comes from the root word Venus, who was the goddess of love, and that was primarily what the derivation of the term will mean. Now, another contact disease, and this will finish the pyogenic cocci, the staph, the strep, the Neisseria, is the illness that we call syphilis. And syphilis is a fascinating disease, and one that I want to spend a little bit of time on. Syphilis causes I forget, the last time I looked, it was about 19,000 cases in the United States. But this is way down in the 30s and 40s. There would be as many as 300,000 cases. So syphilis is a disease that has been around for a long time. It was first characterized or named as an illness in the late 1400s. And the derivation of the word syphilis, I don't know if any of you know where syphilis is believed to be derived from. Syphilis was a shepherd, Anthony. That doesn't mean he was doing anything with sheep, but he was a shepherd. And he was described in a poem by an Italian pathologist by the name of Fracastoro, capital Fracastoro, Fracastoro. Matter of fact, Fracastoro postulated organisms causing infectious disease 400 years before Koch, but this was in the late 1400s. Now, syphilis in the early 1500s was very important as an infectious disease throughout Europe. The French called it the Italian disease. The Italian called it the French disease. People don't know where the origin of the organism comes from. Some people thought Columbus brought it back from the old world to the new world, and there's some evidence that syphilis was over here before it became rampant in Europe. The organism that causes syphilis is a very interesting organism, and it's called Treponema Pallidum. And the organism looks like that. It's very, very long. It's about 20 micrometers in length. It's very, very narrow, less than 0.25 micrometers. And because it's so long and so narrow, you cannot see it with the ordinary light microscope. The organism is an obligate anaerobe. It is rapidly killed when exposed to the air, so you cannot get syphilis from doorknobs or toilet seats or anything like that. It dies very, very quickly. It's a very delicate organism. It is anaerobic and it is motile, but it doesn't have flagella. It moves by means of a filament called an axial filament, which runs through the organism.
Is it mobile? Anaerobic?
Yeah, it's motile. It's anaerobic. You don't stain it. You can't stain it with a gram stain. Perhaps the most interesting and difficult problem for us is that we can't grow it in the laboratory. It is an obligate parasite. So the only way they culture it is in male rabbits. And what they do to grow this organism, if you want to, and we'll show you why you need to grow it, they inoculate male rabbits intratesticularly. And then when they want to get the organism, they castrate the rabbit. They throw the testes into a blender and they blend everything up. And then they isolate the organism from the rabbit testes to culture it, to isolate it. And they're going to use this isolated organism when we go to diagnose the illness. Since you can't culture it and you can't gram stain it, the way in which we diagnose syphilis is by serological tests. And these are called standard tests for syphilis. They go by a variety of names. Most of you are not old enough to have heard of the Wassermann test, the Colmer test. Today we have a test called the VDRL test or the RPR test. And the final diagnosis is going to be by what we call the FTA test. When we talk about syphilis, we use lots of acronyms like OMG or LOL or whatever those things you do on your things. So you'll have a whole new set of acronyms to use. FTA, VDRL, RPR. These are all of the serological tests. So when we go to diagnose syphilis in an individual, we take blood from them and we look for antibodies that we might produce in response to the syphilis organism, or antibodies that we make because the organism has modified our tissue. Syphilis is a fascinating illness because it goes through several different clinical stages, which I'll show you. The primary symptoms appear 1 to 3 weeks and often involve a painless lesion. That lesion is called a chancre, chancre. And usually the chancres are portrayed on the external genitalia. I'll show you chancres on a person's eyelid. Maybe he got his eye too close to someplace, I don't know. A chancre represents where the microbe entered the body. And often they'll show you a chancre on a lip or an eyelid or a chest or someplace. But that disappears. It's a painless lesion. Although, boy, when I'll show you pictures of it, you won't think it's painless. But it disappears. And then about 8 weeks later, you get a rash over your body. It can become very intense on the palms of the hands, the soles of the feet, and then that rash disappears. And then you go through a long latent period for about 20 to 30 years. And 30 years later, you wake up one morning and you're blind, paralyzed, and insane. And we call that tertiary syphilis or neurosyphilis. The organism isn't in your body anymore. It's an immune response to where the microbe was in your body. We have a number of very important people that have died of syphilis or had syphilis. I forget all of them. One of the czars of Russia, I think Ivan the Terrible, Al Capone. Somewhere I read George Washington, but I can't spread that as a rumor if I don't know it. I'll stop here. I'll see you on Friday, is that right? Today is Wednesday, right? Okay. Have a great life. I may hit golf balls again. I was wondering where my caddy is, but he dropped the class.
Yeah. You should have offered him a D if he just stayed your caddy.
His father's a big deal over at NIH. Okay, Bianca, do you get all that?
Yep.
Okay, make sure you read all you can about gonorrhea and syphilis.
I didn't make it in Monday.
I missed you, though.
Well,
Yeah.
I spent spring break in the ICU.
Doing what? Were you a patient?
I was.
For what? An anaphylactic reaction?
Diabetic ketoacidosis. Found out I was diabetic all of a sudden.
You didn't know you were
I
diabetic?
never.
God.
Yeah.
So you're type 2, no doubt. I mean,
No,
you're not
they're
a
thinking type 1.
type 1.
Yeah,
You're
they're
old.
thinking-
You're old for type 1.
I know. They're thinking that it was an autoimmune.
Well, yeah,
I've
but
seen that.
but often in the literature that I read about this is that it could result from a viral infection.
Yeah.
There are reoviruses that infect those beta cells, modify them, and then the immune response targets them.
That's what they're suspecting.
So, are you insulin dependent?
I'm using 20 units of insulin a day.
So you're monitoring your
Oh,
level
yeah.
carefully.
I wrote myself a database to keep track of what I eat.
Well, that's good.
I just wanted to see if you had heard any
About the clinical trials they're putting out for TB, that the antibiotic is much less